Well, we probably have all noticed that some residues break down much faster than others. Under certain conditions or situations, we see a much more rapid breakdown of organic matter than we do in others. So we should review the factors that are going to affect the rate of organic matter decomposition in the soil. Well, if we look at our overall process again, one of the things that's required in this process is oxygen, free oxygen gas, which these organisms obtain from the soil atmosphere. So if we have something that restricts the supply of oxygen to the soil, it would make sense that the rate of organic matter decay would there be lessened or slowed down. And that is indeed the case. So we do have to have adequate aeration. We need a resupply of oxygen to the microorganisms in the soil to break down the organic material. So waterlogging, crusting, puddling, those types of things which can occur from time to time in a soil would be detrimental to the overall rate of organic matter breakdown and cycling of nutrients through the organic matter cycle. In addition to adequate aeration or a resupply of oxygen, we also need, obviously, moisture and adequate temperature. Moisture is important because these are living organisms. They function best in certain moisture and temperature ranges. And so I think that's pretty self-explanatory, the fact that we need moisture and temperature in order to get this process to occur. One of the things beyond this, or beyond those that we've already talked about, that has a very dramatic effect upon the rate of organic matter breakdown in a soil is the amount of nitrogen in that material. Nitrogen is, just like it's the most limiting nutrient for crop growth under field conditions, the higher forms of plants we're growing as a crop utilize high levels of nitrogen, and it's typically not found naturally in the soil in that high of level. Well, these microorganisms are no different. They also require high amounts of nitrogen. So if we put a residue into the soil that has low availability of nitrogen, we would expect that material to remain there longer or take a longer period to be broken down or decomposed by the microorganisms. And indeed, that is the case. How do we know how much nitrogen is in a residue? The best indicator of that is the carbon to nitrogen ratio. In other words, C/N ratio. What that means is that how many carbon atoms are in that material for each single nitrogen atom. And I think it might surprise us to learn that some materials have extremely high carbon to nitrogen ratios, such as 500 or 600 to 1. That means that that material has 500 carbon atoms for every one nitrogen atom. And as you might expect, if you saw a material or had a material that had a high carbon to nitrogen ratio anywhere as close to that range, rate of decomposition or decay of that in the soil would be very, very slow. Well, what are some examples of typical carbon to nitrogen ratios that exist for different types of residues that are added to the soil? If we're dealing with legumes, plants which have the ability in the symbiotic relationship with bacteria to fix their own nitrogen from the soil, these plants are typically very high in protein. And remember, protein is the primary organic constituent in which nitrogen is contained in the plant. So if we have those types of materials like pea vines, alfalfa hay, clover, those types of materials, which are all legumes, we would expect their carbon-nitrogen ratios to be low, and that's indeed true. Pea vines have a carbon-to-nitrogen ratio of approximately 30 to 1. Now that still sounds like a lot, 30 carbons for each nitrogen, but that's actually a very low carbon-to-nitrogen ratio. Anything from about 50 to 1 on down would be considered a low carbon-to-nitrogen ratio. Perhaps 50 to as much as 150 would be somewhat intermediate in terms of the carbon-to-nitrogen ratio. And as we progress above about 150 to 1, we're getting into higher carbon-to-nitrogen ratios, which are going to cause a substantial rate of slowing of the breakdown process, the decomposition process. I'll give you an example. Sawdust from Doug fir, an example of an evergreen tree. Typically, when it's fresh sawdust from hasn't been exposed to the environment and broken down at all, it will have a carbon to nitrogen ratio somewhere in excess of 600 to 1. Well, why There are situations where we would maybe want a high carbon to nitrogen ratio, and then there are situations where we'd want a low carbon to nitrogen ratio. If you're putting a residue into the soil and you want it broken down very quickly to serve as a source of nutrients to a subsequent crop, then you would want a material with a very low carbon to nitrogen ratio because it's going to release those mineralized ions very quickly when placed into the soil. If, on the other hand, you want a residue to remain there for a longer period of time, help maybe provide some protection to the soil, some mulching effect, and or help increase water intake and aeration into the soil, which these organic residues often do, then you would want a material that had a higher carbon to nitrogen ratio. So I think the easiest way to remember this is that low carbon to nitrogen ratio means a rapid rate of decay. High carbon to nitrogen ratio would mean a slow rate of decay. That is what I would refer to as an inverse relationship. As one goes up, the other is going to go down. So in other words, as the carbon to nitrogen ratio goes up, the rate of decay will go down, and vice versa. So that's how we can utilize information on carbon to nitrogen ratios. We pretty well know, or I should say it is pretty well known, what carbon to nitrogen ratios are for various types of plant and or animal materials that would be potentially added to the soil as a source of organic material and or nutrients. So for mulching and holding weeds down and helping protect soil surfaces from drying out and those types of things, we typically lean towards products or plant materials that have high carbon to nitrogen ratio. For the purpose of utilizing organic fertilizers, materials that are going to be releasing nutrients relatively quickly for our current crop to uptake and utilize, in those situations we would want products that had a very low carbon to nitrogen ratio so that they wouldn't fix or tie up nitrogen in the soil, but they would be breaking down and releasing it fairly quickly upon their placement or incorporation into that soil.